So hopefully you were able to follow along with the video okay. Again, what you should have done was you should have plugged in all of the values. So we had 0, 1, 2, 3. We had 0.125 for the 1/8, 0.375, excuse this terribleness, 0.375, and 0.125, I believe. Major shush. After that, you should have gotten the standard deviation of 0.866. So if you did not get 0.866 at this time, go back and try it again. See if you missed anything up. Again, talk to people around you. You have the directions here. You have the video to watch again if you were not understanding how to get to 0.866, but that is the standard deviation. So what does this mean? Interpretation. Oftentimes you're going to be asked to interpret what these things mean. You're like, sweet, 0.866. Well, let's look at the context. The context is, again, talking about the spread of all the possible boys you could have in a family with 3 kids. So our interpretation needs to use that context. So we are going to say the number of boys, because that's our context, in a family with 3 kids. That's important because obviously if there's more kids, then you're going to have more boys. With 3 kids, I remember that what standard deviation measures is the distance from the mean on average for all of our points. So we're going to use that phrasing. The number of boys in a family with 3 kids is 0.866 boys from the mean. I know that sounds weird, but that is our average distance from the mean. So we're going to say that on average. Once more, if we look at each individual data point's distance from the mean, this is the average of those distances. The number of boys in a family of 3 kids is 0.866 boys from the mean on average. And again, from the mean means the distance. So we're going to go ahead and we're going to do just one more thing. We're going to try it one more time, plugging into the calculator, and then we'll pause here and be done. So on example 2, it says you sell 500 raffle tickets and you're giving away prizes of 200, 150, 1 each. Find the expected value of 1 ticket after purchase. I should say after you're given. It's not purchased, it's just given to you. You're not buying anything. And then, let me rephrase this. I don't have time to cut this video. It doesn't matter that you're buying it. Sorry, you are buying it, but the prizes are being given away. You are buying it, but that doesn't affect our answer. It doesn't matter how much the ticket costs. We're not looking at that. We're just looking at your possible winnings. So there's 500 tickets and only 3 prizes. What we're going to list here in these boxes are all of your possible prizes. Well, we know you've got 50, 100, 200, but also that's only 3 tickets out of the 500. What's the other possibility of what you might win then? Nothing, right? So 0 is our first possible value of this variable. There's a very good chance you're not going to win anything. And then you might win 50, you might win 100, you might win 200. So what I want you guys to do is then figure out the probability of these winnings. There are 500 tickets. How many of those tickets would you not win anything on? Take a second to think about that. How many tickets would you not win anything on? Well, if there's only 3 winning tickets, I can actually start here. There's 1 out of 500 that you'll win 50. There's 1 out of 500 that you'll win 100. And there's 1 out of 500 that you'll win 200. That leaves 497 tickets that you will not win anything. So what you need to do is find the expected value, which is again the mean, and find the standard deviation using your Casio just like you did on the last problem. Remember that you need to get these fractions as decimals, and that's what you'll plug in. So try that and then pause the video, and then you can come back and check your answer. Okay, you should have gotten a standard deviation of 10.22 dollars, right? Because this is money we're talking about, and a mean of 70 cents. That means in this raffle, you can expect to win 70 cents. What that means is, in most of the cases, you're not going to win anything, right? So you could expect 70 cents. Yeah. With a pretty large spread, $10.22, and that's obviously because so many of these tickets you win nothing. So this is our average winnings, 70 cents. And this is our spread of those winnings. So tomorrow we will come back and we'll do the last two slides together. I just wanted you guys to get practice in the calculator with doing the expected value and the standard deviation. So hopefully that's okay. From here, if you have anything else to work on, you can. You can also review the vocabulary in the class Quizlet. I have the link there in the posting for today's agenda. There's old stuff from last semester as well as a Quizlet for today's lesson. So that might help you review this content a bit more.